In this video, we're going to be covering the most basic terms and rules associated with the field of probability. And the first term that we're going to discuss is an experiment. And in probability, an experiment is an act or a process that leads to a single event that can't be predicted with certainty. So a most basic experiment that I can think of is just flipping a coin, which has the outcomes of heads or tails. But we can have also much more complicated experiments, like the standard kind of scientific experiment that you might think of, like a biological or chemical type of an experiment. The next term that we're going to cover is a sample point. And a sample point is just the basic outcome of an experiment. So if we're flipping a coin, a sample point could be heads or tails. Or if we're doing like a chemical or biological experiment, it could just be one of the potential outcomes from that experiment. The third term that we're going to talk about is a sample space. And the sample space for an experiment is just the collection of all the sample points of that particular experiment. So for simple experiments like the coin flipping example, the sample space is going to be very small, which is heads or tails. But for more complicated experiments, we could have a very large or even infinite sample space that we're going to have to deal with. Now that we have these basic terms defined, let's look at the most fundamental rules of probability. And the first rule that we're going to need to cover is that each possible sample point is going to have a probability associated with that. We're going to call that probability P sub I. So we're going to say P sub I is equal to the probability of sample point I happening for that experiment. So for example, we would assign some probability of flipping heads in our coin flipping example, and also probability of flipping tails. So each of those sample points in our experiment need to have some associated probability. And we have a couple of rules associated with what these probability values need to be. And the first is that the probability, or P sub I, needs to be between 0 and 1. So we're going to say that 0 is less than or equal to P sub I, which is less than or equal to 1. So for all of our P sub I values, they need to have a probability between 0 and 1, which can be 0 or 1. So that event could be essentially certain, or it could be completely impossible, or any probability in between there. And the final rule that we're going to cover from our basic rule standpoint is that the sum of all of our probability values, all of our P sub I's, need to sum to 1. So for every experiment, if we add up all the probabilities of all the possible sample points, the sum of that probability is going to be 1. So now that we have these very basic terms and rules of probability defined, we're going to cover one final term, and that is an event. And the way that we're going to define an event is just a collection of sample points. So the easiest way that I can think of for describing this is, let's say our experiment is rolling a die. So we have the sample points, or the possible outcomes of that experiment, being the values 1 through 6. We can say that an event is maybe rolling an even number. So that event might be rolling a 2, 4, or 6 from the possible sample points that we have. So it's just a subset of our sample space, which has a collection of possible sample points in there. We can also have what is called a simple event. And a simple event just has a single sample point in there. And we also have what is called a compound event. Which is an event that has at least 2 sample points associated with it. So more than one sample point. So now that we've defined what an event is, we need to understand how to actually find the probability of that event. So we're going to use the notation P, parentheses event. And this notation is just saying what is the probability of whatever inside the parentheses is of occurring. So what is the probability of that event? And the probability of that event is just equal to the sum for all the PI's associated with each sample point in that event. So the sum of all PI's where I is associated with a sample point in our event. Now that we know how to find the probability of a particular event occurring, let's walk through the steps of actually finding that probability. So we're just going to say, what are the steps for finding the probability of an event? And there are 5 steps that we're going to walk through. The first is we're literally just going to define our experiment. And by this I mean we're just going to define how our observations are made and the types of observations that we're trying to record. So for example, if our experiment is a baseball game, we might have a whole slew of different observations that we're trying to record. Maybe it's the number of strikeouts, maybe it's the number of home runs, or maybe it's just the win or the loss. We need to define what those observations are that we actually care about. Number 2 is list all the sample points. So for simpler experiments like coin flipping or maybe even the baseball game, listing all the sample points might be relatively easy to do. For more complicated experiments, you might just need to list ranges or kind of an explanation of what the possible outcomes from that experiment might look like. Number 3 is we assign probabilities. So we assign probabilities for each of our sample points. And each sample point in our experiment needs to have an assigned probability, and remember it needs to follow those probability rules, where each piece of I is between the values 0 and 1, and the sum of all the piece of i's. And the sum of all the piece of i's is equal to 1. The 4th step is we need to determine the sample points in the event of interest. So we need to determine sample points in our event. So for our dice example, we might say that the sample point that we want to see are an even die roll, so 2, 4, or 6. So we just need to kind of lay out what that event actually looks like in terms of sample points. And now that we have all those sample points defined and their associated probabilities, the final step for finding our probability of our event is just summing the sample point probabilities. So summing the piece of i's for all of the i's in our event. So what we mean by this is, let's say for our dice example, we want a 2, a 4, or a 6. And if we want to figure out the probability of that event happening, we need to find the probability of each of those sample points occurring, and then we sum all those sample points together.